This is part 8 of the series Transformations, and in this part we're going to continue working on dilation examples. Last part we worked on this example, which was a dilation with a scale factor of 2 about the origin. Now we want to do a dilation of the same triangle ABC. This time we want to dilate it about a center of dilation of 2, 1 with a scale factor of 2. So it's the same scale factor as before, but we have a new center of dilation. So let's go ahead and calculate that. First thing I want to do is I want to write down my points. Now, organization of work is a very critical thing. So I'm going to put point A as 1, 2, point B as 1, 4, and point C as 4, 4. Now, we're going to do the dilation about 0.21. So A prime is going to be, first thing we want to do is we're going to take the point, subtract off the x-coordinate of our center, multiply by our scale factor, and then add back that point of center of dilation. So it's minus 2 plus 2. Now this gives us our x-coordinate. And our y-coordinate, we're going to do something very similar. So we put the scale factor out here. We take the y-coordinate now. We subtract off the y-coordinate of our center. And then add it back. So we've done the same thing. We've taken the y-coordinate of our point, subtracted off the y-coordinate of our center of dilation, multiplied by the scale factor, added that point back. So that's A prime. B prime is going to give us, we're going to do something very, very similar here. We're going to take our scale factor, take our point, subtract off the x-coordinate, which is the same as this, subtract off the 2, then add the 2 back. Do the same thing we did here. 2 times the y-coordinate of this point minus 1 plus 1. Because we're subtracting the same y-coordinate from each one of the y's. So we subtracted off the x, x, y, y. And that gives us our x-coordinate and our y-coordinate. Do the same thing for our C prime. So we take the x-coordinate of our point, 4, subtract off the x-coordinate of the center, add it back, multiply by the scale factor. And the same thing that we did here. The y-coordinate minus the y-coordinate plus the y-coordinate back. Notice, minus 1 plus 1, minus 1 plus 1, minus 1 plus 1. Minus 2 plus 2, minus 2 plus 2, minus 2 plus 2. So if you organize your work right, this becomes fairly easy. As long as you figure out the first one, the rest of them are fairly straightforward. They're just repeats. The only thing you're changing is the x-coordinate of your point and the y-coordinate of your point. Now that's all we have to do is do the arithmetic here. So we have 1 minus 2 is negative 1, times 2 is negative 2, plus 2 is 0. 2 minus 1 is 1, times 2 is 2, plus 1 is 3. This one, 1 minus 2 is negative 1, times 2, negative 2, plus 2, 0 again. And we have 4 minus 1 is 3, times 2 is 6, plus 1 is 7. And then for the last point, 4 minus 2 is 2, times 2 is 4, plus 2 is 6. And 4 minus 1 is 3, times 2 is 6, plus 1 is 7. So these should be the 3 points for our new dilated figure. And just to verify that our calculations are correct. Let's move over to our geometry software and verify that this is in fact the dilation. So here we have our original figure at 1, 2, 1, 4, and 4, 4. We have a center of dilation of 2, 1 and a scale factor of 2. And so we see we have 0, 3, 0, 7, 6, 7. Notice how all the points fall along lines that go through the center of dilation. So yes, in fact, we were correct. So again, it's not that horribly difficult. You just have to track your work, organize your work properly, and it's not all that hard. Let's go ahead and work another example. Now this is a completely different type of example. It's asking us to find the scale factor of the dilation and then to state whether it's an enlargement or reduction. And we don't have any coordinates of the points. What we do have is corresponding segment lengths. We have segment AB here and segment A prime B prime. And so what we're going to do is we're going to use those to determine the scale factor. Now, scale factor is nothing more than a ratio. It's a fraction, a comparison of two numbers represented as a quotient. And so the ratio is always going to be destination divided by source. That's what scale factor usually translates down to. So let me write that down for you, just so that you have that in your head. So scale factor equals destination divided by source. In this case, destination is represented by the distance from A prime to B prime. So these primes are our image points, and the primary points of our preimage are A, B, and C. So AB is our preimage value, the source, and A prime, B prime is our destination. So our scale factor in this case is going to be destination, which is 10, because that's the image length, divided by source, which is 4. And that simplifies to 5/2. So our scale factor for this dilation is 5/2. Since this number is greater than 1, so this is greater than 1, we know this is an enlargement. All right, let's move on to another example. Here we have another dilation of a triangle about a point that's not the origin. This time it's a reduction because we have a scale factor of 0.5. So let's begin by writing our points. So you have A is 6, 8, B is 4, 12, and C is 12, 10. Now our A prime is going to be, our scale factor is 1/2. We take our point, we subtract off our center of dilation. I'm going to put that as point P as 4, 2, just so that I have easy reference up here. So it's 6 minus 4 plus 4. So we subtract off the x-coordinate, add it back. Then for the y-coordinate, it's scale factor, y-coordinate, 8, subtract off the y-coordinate, add it back. Then for B prime, that's going to be looking very similar. Now we take this x-coordinate, 4, and we do the same thing here. We're subtracting and adding the same x-coordinate. So minus 4 plus 4. Then 1/2, 12. And we do the same thing here. Minus 2 plus 2, because that's the y-coordinate. And then C prime is 1/2 and we have 12 minus 4 plus 4, 1/2, 10 minus 2 plus 2. Now we just calculate these, and we have 6 minus 4 is 2, divided by 2 is 1, plus 4 is 5. 8 minus 2 is 6, divided by 2 is 3, plus 2 is 5. 4 minus 4 is 0, divided by 2 is 0, plus 4 is 4. 12 minus 2 is 10, divided by 2 is 5, plus 2 is 7. And lastly, 12 minus 4 is 8, divided by 2 is 4, plus 4 is 8. And 10 minus 2 is 8, divided by 2 is 4, plus 2, 6. Let's again go ahead and verify these values in our geometry software. Here we have the center of dilation at 4, 2. We have our preimage at 6, 8, 4, 12, 12, 10. Scale factor of 0.5. And in fact, it comes out to 5, 5, 4, 7, 8, 6. So we were correct again. All right, let's go back. Now, ordinarily, you'd want to go ahead and graph these points. I didn't do that in the last examples in this one, but feel free to do so if you need practice plotting points. And let's move on to the next concept. The idea here is similarity transformations. We had congruence transformations in reflection, translation, and rotation, where angle and length are preserved, but in dilation, length is not preserved. Angle is preserved, but not length. That makes a similarity transformation, which is a dilation, a composition of dilations, or a composition of dilations and other rigid motions. And that brings up the idea of similar figures. Similar figures are two figures that have a similarity transformation that maps one figure onto the other. So two figures are similar if and only if there is a similarity transform that maps one to the other. And you can think of it as it has the same shape but different size. That's what similar figures are. And so let's look at some of these compositions and see if we can work one out. In this example, we have this triangle, and we're doing a composition of a translation followed by a dilation. So let's first do the translation. Here we took point A, B, and C, and we subtracted 2 from the x. So 2 minus 2 is 0, 6 minus 1 is 5, 2 minus 2 is 0, 3 minus 1 is 2, 5 minus 2 is 3, 3 minus 1, 2. Now we're going to do a dilation about the center 2, 1 with a scale factor of 2. Now we've done these a number of times, so let me go ahead and do that. And here we have A double prime, which is the dilation. We take the scale factor, and we take our point. We're using this point, and this point. We're not using the preimage points. So it's 0 minus 2, which is the center of dilation, plus 2. Then 2, the scale factor, y coordinate now, using this y coordinate, not this one, 5 minus 1, which is the center of dilation, plus 1. That equals negative 2, 9. Doing the same thing with this one. Scale factor, point, minus 2 plus 2. Scale factor, point, minus 1 plus 1. That's negative 2, 3. Then scale factor, 3. That's the x-coordinate of our point. Minus 2 plus 2. Notice all the minus 2 plus 2's. Scale factor, point, which is another 2 here, minus 1 plus 1. So this gives us 4, 3. And there is our similarity transformation, which is just a composition of a translation followed by a dilation. Well, that wraps up this series. I hope it was helpful to you, and I will talk to you in the next series.